Alright, so moving on to 9.2, the alkenes. Now alkenes are like alkanes, except somewhere in the carbon chain there is one or possibly more carbon double bonded to another carbon. Let's have a look at how that works first. We know that carbon, being a 2,4, having 6 electrons, it has 2 electrons in its first shell, 4 in the outer shell, and so it looks like this. And what we did previously with the alkenes was we took multiples of these carbons and we were able to see that we could link them together by putting them next to each other. Just give us a tick. That's better. And we can see that they make pairs of electrons like that. Now with this one, what we're going to do is we're going to do that there. Actually, I'll just grab a copy of that so I can use that later on if I need it. So I can take this carbon and I can slide it over here, and what we can see now is, just as before, this pair of electrons is forming a single bond there, and now each of these carbons has 5 electrons in its outer shell. We can do the same thing by taking this electron here and sort of bringing it up here and this one up here, and they can make another pair like this. And so what we get from that is carbon 1, 2, 3, 4 electrons between them. It's those 2 there plus this one and this one, leaving 2 electrons on either side like this. And what this represents is that's your first pair of electrons that way, that's your second pair of electrons that way. So when we draw this using the lines instead of the pairs, we draw 2 lines horizontally, one for each of the vertical pairs of dots. And what we've got here is kind of a half bond in each of those 2 positions on the remaining carbon, on each of the carbons, and they're looking for something to bond to, and they bond to other carbons, or they bond to hydrogens in this case, because we're just dealing with hydrocarbons. And it might actually be easier if I remove those and just show them as the dots. That might actually be a bit easier. So we've got, let's just do that. Let's have a dot here, a dot here, a dot here, and a dot here. Now before we do anything else, let's have a look at the electron count for each of the carbons. This carbon has 1, 2, 3, 4, 5, 6 electrons around it, and this carbon here has 1, 2, 3, 4, 5, 6 around it. So it's going to want to bond with other things. Now we can bond them with hydrogens. We can do just a tick. Just take that and park it out of the way over there. Don't need that anymore. We can bond them with hydrogens, and so I could pop a hydrogen in there. I could pop a hydrogen there. I could pop a hydrogen there, and I could pop a hydrogen there. And as before, we're using the hydrogens to fill in gaps. And now we can see that each carbon has 1, 2, 3, 4, 5, 6, 7, 8 electrons for that one. This one, 1, 2, 3, 4, 5, 6, 7, 8. So both carbons are satisfied in this situation here. And if we were going to draw that with sticks showing all of the electron pairs, we'd get carbon double bonded to carbon like this, like this, like this, and this. And that is in fact the first of the alkenes. It's called methane is the first one. Then you've got ethane. But it's not an ane, it's not an alkane, it's an alkene. And so what we do is we change this A, actually I'll do that with a pen. We change that A for an E to mean double bond, and so this one is called ethene. Okay, and that's C2H4, and it's got the chemical general formula of CnH2n, and we'll see that when we have a look at the next one, which will be the propane version with a double bond, which will be called propene. Let's have a look at that now. Now what we'll do is we will start with tacking on an extra carbon into one of these positions here, like this, and then it of course has 1, 2, 3 electrons around it. It's got 4 electrons around it. I used one of the electrons there to form a bond with this carbon double bond carbon thing that I've got here. And now I've got 3 carbons in a row, and that will be drawn like this, like that. And methane, ethane, propane, this is then propene with the double bond giving it the ene at the end. And of course what we can do is we can fill in the gaps with hydrogens like this. You excuse my kind of half using sticks and half using dots, but I want to show the actual double bond clearly in this drawing. Anyway, the book doesn't seem to mind mixing its methods. Not that that's an excuse. And so we get this. And what we have to check here is that each carbon has 4 lines joined to it, because each line represents a pair of electrons, and when you've got a stable molecule it will be 4 pairs for each carbon, meaning it's got 8 electrons in its outer shell. So we check this one, 1, 2, 3, 4, that one's good. That one's all right. This one here, 1, 2, 3, 4. That one's good. And this one, 1, 2, 3, 4. That one's good. Propene, no worries. And again, here we can see that if we count up the carbons, we've got 3 carbons and we've got 6 hydrogens. So once again, it's using the CnH2n general formula. Wow, that's a mess over there. Anyway, we'll carry on. So let's have a look at the next one. Oh, before we do that, I'll just do it as the dots and the sticks thing that I did for the alkenes. So in this one here, we've got 3 carbons like this. For ethene, we would just have the 2 dots and we'd have 2 lines joining them like this. This one here is the same. We'd have that and then a single bond there. And in fact, this one's drawn without the dots, and it's just drawn like that. That's the simplified version of this thing here. You can see the carbon is the end there, double bond here. Every time you've got a bend or a stop is a carbon, so that's a carbon there, shown on the dot here, and then the bond between them here, and finally ending up at the carbon here. Let's have a look at the next one. So we'll see if we can speed the process up a bit. We've got 4 carbons there, which is methane, ethane, propane, butane. So we're looking for butene this time around. Now what we'll do is we'll speed this up a bit. We'll draw 4 carbons together there. Now what we want to do is we want to put a double bond in there in between 2 carbons. So if you think about it, we can see 2 variants of this. We can put the double bond here, or we can put the double bond here. Now you might be thinking, well, look, I can also put the double bond at the other end there like that. But then if you take this one, watch this, if you take that one and you rotate it 180 degrees, you get the one that's underneath it. So that is not a different molecule, all right? So we've got 2 possibilities for putting the double bond in here. It's either between the first carbon and the second carbon, or it's between the second carbon and the third carbon. Now in both of these, what we can see is 1, 2, 3, 4, 1, 2, 3, 4. The way we tell the difference between these in terms of naming is we need to identify where the double bond starts. And so for this one, it starts on carbon 1 because it's between C1 and C2. And this one here, it starts on C2 because it's between C2 and C3. Okay, so that tells us how to name these things. This one is butane, that's fine. This one's also butene. And we've got to be able to tell the difference between them. So we already used numbers at the front of the molecule. So if the front of the name, the numbers are used for functional groups that are tacked onto the main carbon chain. So we can't put it at the front. What we need to do is we need to stick it in here, in the middle of the butene name. So we're going to stick that information in there. Now the way we do that is we take the but and the ene there, we separate them a bit, and we say which carbon it starts on. So this one is but1ene, and this one is butene, but it's got the double bond starting on carbon 2. Butene, there we go. So with this one, we have 2 structural isomers for just the main carbon chain itself. Now, of course, for C4H8, there are even further structural isomers because you can take this carbon and stick it on here, and you'll get another structure again. So we're finding now that we're getting structural isomers within the chain, as well as by changing the taking bits off and sticking them on in different places. Anyway, let's move on and have a look at the next one, carbon 5. Oops, before I do that, I'll just do a couple of other things. Just occurred to me. So I can get rid of this because you've got it on the video there and you can go back and look at it. So for but1ene, we've got carbon, carbon, carbon. Let's put the hydrogens on here. Now we've got to make sure we put the correct number of hydrogens, and we do that by making sure that each carbon has 4 sticks coming out of it. So you can see here I've only put 1 hydrogen on the carbon in the middle of the chain, but that's because it can only have 4 sticks coming out of it to represent the 8 pairs. And a semi-structural formula, this would be CH2. Do they show the double bond? I believe they do. CH like that, and then CH2, and then CH3 like that. And so there's a couple of different formats for it there. And methane, ethane, propane, butane, yes, and to draw it in stick form, it would look like this, like that. But we're not going to worry about that with this one. It's there if you're interested. But2ene, very similar. But2ene, 1, 2, 3, 4. Put the double bond in the middle, and then we've got the hydrogens go on there. And here we can see 1 hydrogen there, 1 hydrogen there. Missed one there. I knew I was missing one. Yep, that's better. So again, this one would be CH3, CH, CH, CH3, like that. Oh, very nice. But2ene. Fancy. All right, let's try methane, ethane, propane, butane, pentane. Let's try pentane. I'll do that in the next video because I've just about run out of time here. So check the next one.